Well, hello there, and just as Derek and the dominoes play out there, this exciting one for beginning of year 2. I know we've had a couple of things we thought, well, there's nothing that new there other than the questions all got a little bit tricky and stuff, but we're going to do partial fractions today, which is a whole new algebraic skill. So we do need we need a proper biscuit for that. So I'm going with the good old chocolate chip cookie. Can't go wrong with a chocolate chip cookie, as long as you can say it. Right, okay, so partial fractions. Here we go. Here's your first example. We're going to split 6x minus 2 over x minus 3, x plus 1 into partial fractions. There are two ways we're going to do it. We're going to do it by substitution first of all. So I'm going to show you two different ways you can get to the same answer. And this is important because although in an exam you don't have to use both of them, sometimes one is a bit easier, sometimes the other is. And yeah, it's always good to know both. So we're starting off with substitution. So what we can say is that I know that this fraction here is going to be identical to, so that's a 3-line equals sign, something over x minus 3 plus something over x plus 1. I didn't need that bracket there, did I? But never mind. And that something is going to be called A. That's something there I could call B. First thing. Now what would we do if we had this and we were going to add them like we were doing yesterday? Well, we would say that that is going to be the same as, well, we would say, yeah, we're going to end up with that as our denominator, and the A would be multiplied by the x plus 1, and the B would be multiplied by the x minus 3. Now what that means is, if you look from there to there, denominator's the same, that means we can say that 6x take 2 is identical to a number times x plus 1 plus another number times x take 3. Now I want to find out what A and B are, and I'm going to do it one at a time. What is A? Well, if x was minus 1, that would make this bracket 0, and 0 times A would be 0, which would mean I only had B left. So I'm going to say let x equal minus 1, and then here I would say, well, 6 times minus 1 is minus 6. And that's going to be equal to, all of this is 0. I'm then going to have B, and in the bracket, minus 1 take 3, which is going to equal minus 4, isn't it? So that would give me minus 4b. Let's write that out again. So minus 6 take 2 is negative 8, is equal to negative 4b. And then I can divide by negative 4, can't I? And that will give me 2 is equal to b. That's letting x equal minus 1. I've got enough room over here where I could say let x equal 3. Why 3? So that this bracket becomes 0. Now if x is 3, 6 times 3 is 18, take 2 is going to be the same as A brackets 3 plus 1, and the b term is going to disappear because that's worth 0. So that's going to say, right, 16. 3 plus 1 is 4, so that gives me 4a. And if 16 is equal to 4a, then 4 is equal to a. And what does that mean we can say? Well, that means I've just got room under here that means I can say that 6x minus 2 over x minus 3 x plus 1 is the same thing as a is 4 over x minus 3 plus b is 2 over x plus 1, and that's for any value of x. Look how much simpler that is. Now that is going to have really great repercussions later on in year 2 when we start looking at binomial expansions and also integration. I don't want you to worry about how it's going to be, but this is important stuff. So that's by substitution. Now I did say we were going to do it by another way. We're going to do it b by another new term, equating coefficients. Equating coefficients. Have a think about what those words might mean. Equating meaning making equal to, coefficients, the numbers in front of the x's. Right, so let's have a little look. What was our question again? It was 6x minus 2 over x minus 3 x plus 1. And we're still wanting to say that's going to be identical to a over x minus 3 plus b over x plus 1. And we can still go back to the same thing we were talking about before, where that means that 6x minus 2 is going to be identical to a x plus 1 plus b x minus 3. So that was all through the bit that we did earlier. And if we expand the brackets now, we get the fact that 6x minus 2 is identical to ax plus a plus bx take 3b. Now the equating coefficients means, well, we've got so many x's and we've got so many normal numbers, so we can say for x 6 is going to be equal to a plus b, and I'm going to call that for c as in the constant that's in here. So we've got minus 2, and that's going to be equal to a minus 3b. And what have we got here? We've got a simultaneous equation. Now if I take the bottom one from the top one, I get no a's at all. 1b take negative 3 will be adding 3, won't it? Will give us 4b. Taking negative 2 means adding 2 to 6 to give us 8. Therefore b is equal to 2. And then we can substitute 6 equals a plus 2, plus 2, and therefore a must equal 4. And at that moment we can go back up here and say that that would be all identical to 4 over x minus 3 plus 2 over x plus 1. So we've done it the other way, another way. Now they obviously can get it a little bit trickier, so have a little write down of this. Now this question is the sort of thing you might get. It's an exam question which says 6x squared plus 5x minus 2 over x, x minus 1, 2x plus 1 equals, and then they've split it up for you at the beginning, so they want you to find the constants of a, b and c. Now you can do this by substitution or by equating coefficients, or you can mix it up a little way between. Now in the textbook they just do it by substitution. I'm going to do a little bit of both, and there's a reason for that. But first of all, the next thing to do is to make sure that we know what 6x squared is going to be plus 5x minus 2 is going to be equal to by doing all of the multiplication of the top parts. So the top parts, numerators, now come on. Right, okay, so we've got, so I'm going to be saying that a over x plus b over x minus 1 plus c over 2x plus 1 is going to be equal to, and then we're going to put the whole denominator in as it is originally, and the a is going to have to be multiplied by x minus 1, 2x plus 1, and the b is going to be multiplied first of all by the x, and then the x minus 1, and then the c, hopefully I've just got room here, is also going to be multiplied by the x, and then the 2x plus 1. So now we're going to take all of these and put them up here. So I've got 6x squared plus 5x take 2 equals, and we're going to have all of these guys in here. So a x minus 1, 2x plus 1 plus b x minus 1 plus c x 2x plus 1, like that. So I'm going to say let x equal 0. So this is substitution. That's going to wipe out all of those and all of those. And it's also going to mean that we can say, right, well, if x is 0, that will be 0, that will be 0. That means we'll have minus 2 on this side. And we will have a times negative 1 times 0 plus 1 is 1, isn't it? So negative 1 times 1 is negative 1. So therefore we can say negative 2 equals negative a. Divide both sides by negative 1, and 2 is equal to a, or a equals 2. If I wanted to at this point, I could say let x equal 1 and carry on and do that same process, or I can mix and match, so which I quite like doing. So just see what happens here. You might like it, you might not. So then I can say, well, if a is equal to 2, I can substitute that in and sort it all out. So I've got 6x squared plus 5x minus 2 over here. I've then got 2. If I times that by the first bracket, I get 2x minus 2, and I'm going to need to expand that bracket. I can expand this bracket easily enough. Bx squared minus bx, and I can also expand this one to give me plus 2c x squared plus cx. And if I just expand this now, 2x and minus 2, 2x and plus 1, I get 4x squared, 2x minus 4x minus 2. Sum those together. Just bear with me for a moment. It's going to give me 4x squared, take 2x, take 2. And I've got my other stuff here, minus bx plus 2cx squared plus cx. I can clean this up a little by taking the 4x squared from both sides, gives me 2x squared, add 2x to both sides gives me plus 7x, add 2 to both sides gives me nothing there, and that's therefore going to be equal to bx squared minus bx plus 2cx squared plus cx. And now I can do the equating coefficients for the x squared coefficients. We can say 2 is going to be equal to b plus 2c, and for x we can say 7 is going to be, I've got minus b and I've got plus c there, and that's a nice little simultaneous equation, positive and negative. If we add the two equations together we get 9 and we get 3c, therefore c must be 9 divided by 3 is 3, and then we can substitute back into there to say b plus 2c, b plus 6 is equal to 2, therefore b is equal to negative 4. Now we've got to use all of that to come back to what we were doing over here, haven't we? So we've got a is equal to 2, so we can say a equals 2, and we've got the b and the c there, so we can say that the whole thing of 6x squared plus 5x take 2 all over x, x take 1, 2x plus 1 is 2 over x plus b, which is minus 4, that's rather annoying, I should just say take 4, shouldn't I, over x minus 1, and then it's plus 3 over the 2x plus 1, and I got all of that from back here right at the very beginning where they put it in the question. Okay, now that's quite a lot to take on board, so you might want to watch it again. You might not want to mix up, you might just, if you're starting with substitution, just keep substituting each time. That might be simpler, but I think it's always good to take your time and explore everything you can about both methods when you're given two different ways of doing something. Now this is going to be page 11, exercise 1D, and questions 2, 4, 5 and 7. If you can get the hang of those, then you pretty much cracked this one. Alright folks, see you next week.